and suspension and flux trapping effect. So these are the simple characteristic features involved in the superconductors. Yttrium barium copper oxide is the superconducting material, and this disc is the superconductor. Now he is used a metal spoon, and it will not create any attractive force over the metal. Now he is keeping the magnet over the superconductor. It will not create any mode of attraction or repulsion. Now that metal spoon attracted the magnet. Now we have to reduce to the temperature for the critical field of 77 Kelvin using liquid nitrogen. Now this liquid nitrogen is boils and reduce the temperature to 77 Kelvin. 77 Kelvin is the critical temperature for the superconductor. Superconducting critical temperature. Now it reaches the 77 Kelvin. Now this metal is fully becomes a superconductor. This material becomes superconductor and at zero field. So here we are not giving any magnetic field. Now you can see applying the magnetic field. After it becomes a superconductor, when you can move the magnet nearer to the superconductor, it repels and is moved away. Now by applying the force, that repulsion because of Meissner effect. Now applying a force over the magnet, and you can withstand that magnet over the superconductor. That is called as flux trapping effect. So what is flux trapping effect? Actually the magnetic flux lines which will be existed over the magnet. At the same time, these superconducting magnets has the repulsion force because of the Meissner effect. So continuously the magnetic flux will be repelled by the magnetic flux generated by the magnet. That's why this magnet and the superconductor levitates over certain distance. And at the same time the magnetic flux lines fully circulated over the superconductor and it is trapped. That's why we call that as magnetic flux trap effect. So now at the same time, within this effect, this superconductor is suspended over the magnet. Now applying a force, they are discharging the superconductor and the magnet. Again they have to keep it near, it is attracted. So it is just like a normal magnet, but in the normal magnet there is no gap between the one magnet to the other magnet, but here there is a gap between the superconductor and the magnet. Now you can change the poles of the magnet. What happens? It repels, it moves away. At the same time it attracts, its flux line is inversed, and according to the flow of flux line it attracts again. So with this phenomena the magnetic train is working. So these are the three important parameters we have discussed, and then with this phenomena of superconductor the magnetic trains are working in the large scale. So this is the magnetic train, superconducting magnets used trains in China and in Japan. Now I conclude certain material possess zero resistance at low temperature. This phenomena is called as superconductivity. Next phenomena is the Meissner effect. When the material under the normal state, it means the temperature is greater than the critical temperature, the magnetic flux line easily penetrates the superconducting material. At the same time, when the temperature is less than the critical temperature, the magnetic flux lines are not penetrated, it is pushed out. This effect is called as a Meissner effect. Next, we have to move on to the different types of superconductors. We are classified as type 1 and type 2 superconductors. Type 1 superconductors are basically we say that as soft superconductors. It possesses two states, normal state and the superconducting state, and it obeys the Meissner effect. When you can go for the next type of superconductors, that is called the type 2 superconductors, it does not obey Meissner effect and it is considered as a hard superconductor, and it possesses three states, one as mixed state, other one as normal state and superconducting state. Finally, we have discussed different types of applications. Thank you.